Welcome back to Object-Oriented Programming with C++. Today we're going to look at Lesson 1 and Lesson 2. So let's let's go over to our syllabus and scroll down to Lesson 1 and 2. So Lesson 1 is called What's Your Type, and Lesson 2 is called Getting Operational. So first we're going to talk about data types, and then we're going to talk about operators, and we're going to try to do this in one video. So we'll quickly open up our Lesson 1 and 2 worksheet, and we see a summary of data types. There's int, double, char, string, and bool. Bool, char, double, and int are called primitive data types. They were inherited from the C programming language. String is not a primitive data type. It is a string together of characters, or of char data types. So if you want to look at a string, an easy way to think of string is like that arts and craft exercise you did in senior kindergarten, where you took a string and you put some beads on the string and made a necklace out of it. Maybe you had some beads that had letters. So let's say I wanted to make my name Stephen. I would take the S, the T, the E, the V, the E, and the N, and string them together, and it would read Stephen. And I would tie that around my neck, and I'd have a necklace with my name on it. So that's kind of how strings work. We string together characters, and in that way they're limited by the amount of memory you have access to. They don't have just 1 byte or 8 bytes or 4 bytes. They're a little different. So the important thing to notice in the description of int is that it's 4 bytes and it represents an integer number. So that's like -1, 0, 1, etc. And it's only 4 bytes in memory. The double is 8 bytes. It takes twice as much space as the int, and it represents a real number, and it has up to 15 digits of representation. So an int can go inside a double because the int is 4 bytes and the double is 8 bytes, so there's no problem storing something smaller in something larger. But double cannot fit inside the int data type. Double is larger and the int is smaller, so it's like putting a big box inside a little box. It doesn't work. The char data type is 1 byte, and it's a symbolic character encased in single quotes. And the bool is 1 byte as well. It's a true or a false, and it's used for performing a type of arithmetic called Boolean arithmetic. It's logical operations. So if this, then that. It's a little bit philosophical. It's a lot of fun. So let's, now that we got an idea of our data types, so int is an integer, double is a real, char is a character, string is a string of characters, and bool is a true or false used for Boolean arithmetic. Let's look at the assignment operator, and we'll open up C++ Eclipse, create a new project, a new C++ project. Okay, we'll select the Hello World project and we'll give it a meaningful name like Lesson 1 and 2, data types or just types and operators. Okay, so time to work on our Kung Fu moves, our programming Kung Fu. Come on, load it up. Okay, here it goes. So we have, just in case you don't remember from our first video, these are called multi-line comments, and this is called a single line comment. So here, whatever over here, I can make more than 1 line of comment. A comment is something that the compiler will ignore. It's just there to help you and other people understand your source code. The compiler doesn't see it, so it doesn't care. So let's look at this statement here, hello types. We see a bunch of characters strung together, so you guessed it, this is a string. When we create strings, we put them in quotes, like the double quote. And this is called a string literal because it will always literally be this. So let's go ahead and create ourselves an int data type. We'll call it int a, and we'll close that. That special character you see here, the semicolon, is a line terminating character. It tells the compiler to read this as one statement. So for each statement that you create, you would want to terminate it with a semicolon. Now, normally we try to keep one statement to one line because it's easier to read that way. So that's a convention that we're going to continue to follow. Let's change this to something that's going to be a little bit more meaningful to us. The value stored in A is less than less than, add an A. Okay, so we have an int A. We didn't set it to be assigned any values, so what do you think will happen when we output the value of A to the console? You might think that the value that comes out is a 0. In some languages that might be the case. The binary is not found. What's happening here? Okay, so let's build it and let's run it. Okay, so we're going to select min-gw as our configuration. Okay, so we see a big number here that is absolutely not 0. Don't know what that beeping was. It's news to me. Okay, let's try it again. That's kind of strange, right? You would probably not expect this huge number to be stored in the int A. Let's do it again, see what comes out. Okay, this is extra curious. A different value, completely different than the one we saw before, is now stored in A. So what the heck is going on here? What happens when we do this is every time we run our program, our console application, it's assigned a new position in memory, and we ask for a storage space A, and we ask for it to have the type int. So we say that in this piece of memory we would like to store integer numbers. So we assign a chunk of our memory space to be represented by the variable A. Memory's a little bit messy. It doesn't just automatically write to 0 every time you turn your computer on. That would take forever. So when you're done using memory, it just stays whatever it was before, and it doesn't change until it's overwritten. That way we don't have to waste hours upon hours at trying to boot up our computer and make all like 8 or 16 gigs of our RAM zeros. So what happens here is that A has not been assigned anything initially, and over here it's complaining. It says uninitialized local variable A is used. It's a warning. It doesn't create an error. It doesn't blow up the program. It'll still run, and it might cause you lots of confusion. So you probably don't want to ever do this ever. So let's call A, let's immediately assign A, or initialize it to a value of 0. And let's create a double called B. We won't use B yet, so let's recompile and run. And the value stored in A is 0, which is exactly what we wanted the value stored in A to be. And we'll get rid of this comment because it's now no longer meaningful. Okay, let's create a new line, and we'll say the value stored in B is, and we'll remember to change that. So if you're guessing that it's not going to be 0, then good job, because it probably won't. And if we look at that, it's 2.98 times 10 to the minus 305. So that's pretty neat. It's a double type, so it's saying this chunk of memory space will now represent a decimal place number, a real number. So over here we have a definite real number, much, much less than 0. And if we go ahead and initialize this to a meaningful value like 0, we don't have that problem. So let's go ahead, and now they'll both be equal to the same thing. Perfect. Let's call A a value of 5 and B a value of 2.7. Okay, so let's make a new int called C. And we'll say that C will initialize C to be equal to A plus B. Okay, so what do you think is going to happen here? We said that the int being small can fit inside a double, but the double being large cannot fit inside an int. So let's go ahead and comment this line out. Take a look at the value C, and we'll code that out. And what do we think is going to happen here? Do you think 2.7 will be rounded to 3? Do you think it will know how to round and do that for us? Or do you think it won't round? Do you think it'll complain and explode? Let's see what happens. Okay, it's not exploding, but the value is 7. So A is 5, so 5 plus 2 is 7. What happened to the 0.7? It did not round up to 3. It didn't round down either. It did what's called truncating. It threw away that extra information. 4 bytes is much less than 8 bytes. It's half the amount of information. So what do we do with the extra information? We fill as much of it as we can and then throw away the rest. So the 0.7 got truncated off and it's now a 2. And as you can see, the compiler did not complain at all. So that could be a problem. Now let's try to avoid that always. In the future, we'll avoid that by creating variables that are meaningful to the other variables in the statements. So if A is an integer and if B is a double, then C must be a double in order to retain information. So let's see what happens. Now we should see something a little bit more meaningful. We see 7.7. That's exactly what we want to be seeing, right? 5 plus 2.7 is 7.7. So everything looks quite good here. Alright, so that's enough for this video. We'll take a look at the rest of our operators and data types in another video, maybe in 2 more videos. So that's the end of part 1 for now. Keep working on your Kung Fu and happy programming. I'll see you next time.